Good morning, good afternoon, good evening. Welcome to lecture 3. We want to find the root. What do you mean by the root of an equation? The root of an equation is that if you substitute x in that equation, you are going to have 0. Are we together?
Yes,
For
sir.
example, if you say x raised to power 2 plus 5x plus 6 is equal to 0. A root of this equation is x equals 2. When you put 2 there, what are you going to have? You are going to have 4. I'm coming. Sorry, x equals minus 2 is a root of the equation. When you substitute that, that's going to be what? 4 minus 10 plus 6. What are you going to have? You're going to have 0. That shows that minus 2 is a root of that function. If we put x equals minus 3 is another root. When you put minus 3 there, what are you going to have? You're going to have 9 minus 15 plus 6. I'm sure you're going to get what? You're going to get 0. So when you are talking of the root of an equation, when you substitute that root to the equation, you're going to get 0. Now, that's the problem we want to solve. I'm not going to be reading line by line for you. You're supposed to be doing the reading. So they are giving you a theorem there. I don't expect you to memorize theorems, but I expect you to be able to understand how to solve problems. I'm not interested in memorizing theorems. We can use a graph to find the root of an equation. When you plot a curve between 2 points, wherever that curve passes through the origin, this point is the root. What did I say? This point where the curve passes through the origin is the root. Which means this is giving us some idea. You see, how did we stumble on methods? We just reason. Hello? That means if you substitute x equal to a into the expression, you will get negative, isn't it? When x equals a, the value of the function is what? Is minus. When x equals to b, the value of the function is what? Is plus. When we plot the curve, there is a place where it will cut the x-axis. That is the root. That's the solution. Based on this approach, we can be doing trial and error to locate the root. Hello? Do you know what is done? When we see that we find a and b, we see that this is negative. The next thing we are going to do is we divide x and a, x equals to a, x equals b. We divide it into 2. We add them together and divide to 2. We come to the middle. We come somewhere to the middle here. When you find the value of a function, it is going to be what? Negative. But the negative is reducing. We have idea that we are approaching where it will be equal to 0. Now, we'll take this point now and this point. We divide into 2 again. We call middle way. Hello? When we call middle way, we calculate again, we are getting negative. We know we are approaching, but we are not there. When we divide again, we come back somewhere here. When we calculate, we are now getting positive. You are past it. What do I say? You are looking for something. You have not gotten there. You now realize you are past. You move back a little bit. So that's the approach. So you can use graph to solve the problem. The first method here is that if you want to use graph, So if you are giving an expression, like this, example 2.1, you can break it into two. You can say log 10x, x log 10x equals 1. You can say log x to base 10 equals 1 over x. You can then break it into two. You can say that, so you can plot log 10x and then also plot 1 over x. Wherever the two meet, that's where you have your solution. That's where you have the root. You can see they plotted y equals 1 over x, y equals log x to base 10. Wherever the curve meets, that's where you have the solution. So you can use graph to solve your problem. Example 2.1, done. What do I say?
Example 2.1, done.
And there are answers there anyway. So when I say done, that means what? Go and do it. Now, 2.3 is on method of bisection. We are using method of what? Bisection. We learned it from that graphical method. Why did we learn it? From the graphical method. If we can locate 2 points, look at my hands. If we can locate 2 points, we are sure maybe it is in between. We'll calculate the value of the function for this extreme. We calculate the function. So let me use the table to illustrate for you. Let me use the table to illustrate for you. You can still read what he's saying, but let us use the table. You see, the best way to learn something is to watch an example that has been done. If you want to know how to prepare about, you don't need to go to school because of that. Just watch grandma or mama cooking eba, and you are going to know how to cook eba. So example 2.2, solve the equation for the root lying between 2 and 3, correct to 3 significant figures. So we have this expression. It will now tell us that the function f of x equals x cubed minus 9x plus 1. So when x is equal to 2, the first extreme, we are looking for the solution in between 2 and 3. So what we're going to do is that when you calculate when f is equal to, when x is equal to 2, you got minus 9. When x is equal to 3, you got 1. Please try it to put 2 in that expression. That'll be what? 2 raised to the power 3, that's 8. Minus 18, that's minus 10 plus 1, that's equal to minus 9. When x equals 3, let's put it, that'll be 27 minus 27 plus 1. We know that the function was minus 9 at 2, and by 3, that's become 1, which means the function will have increased from minus 1, minus 9 to minus 4, minus 2 to 0 before you get to 1. We are looking for the situation where the function becomes 0. We are looking for the root. So what we are going to do, if you see this table, we will be making attempts. We will be numbering our attempts. At 0, when we are just starting, we make A to be 2, we make B to be 3. We have calculated for 2. We saw it was minus 9, isn't it? They did not write it in this table. There's also they are actually supposed to write it on the table, but no problem. So what we are going to do is that please see, N is our attempt. Are we together? A is the leftmost, B is the rightmost, and X N plus 1 is our solution, our current solution. And the F is the value we get when we put that solution in that expression. Hello? To get X from here, and what we are going to be doing is we are going to add A plus B and divide by 2. A is 2, right? B is 3. So add it. We are going to have 2.5. Now put 2.5 here. We are going to get minus 5.8. Hello? When it was minus 2, we got minus 9. Now we are getting minus 5.8. What impression do we have? We are moving closer to the solution. Are we together? Say yes.
Yes.
Say yes.
Yes.
Say yes. Now,
Yes. Yes.
now we are going to now replace this 2.5. We are going to replace 2 with 2.5 under A. Are we together? Say yes.
Yes.
We are going to replace. Why are we replacing?
Yes, sir.
We know that 2 is not a solution. 2.5 is getting us closer. We are no more looking at 2. Our solution is likely
Yes,
to be
yes.
5 and 3. Our solution is likely to be what? Between 2.5 and 3. It cannot be between 2 and 2.5. Now, based on this value now, we calculate a new x. 2.5 plus 3 divided by 2. What do we have? We have 2.75, right?
Yes, sir.
Put 2.75 in that expression, we are going to have minus 2.9. We have an equation of what? We are moving closer and closer. Now, but we are not there yet. So what we are going to do is that this 2.75, we are going to use to replace A. Our solution cannot be less than 2.75. Our solution is likely to be between 2.75 and what? You know we are moving. Listen. Now, substitute that 2.75 plus 3 divided by 2. You have 2.88. He has approximated. You put this inside this. What do you have? Minus 1.03. Are we moving closer to the solution?
Yeah.
We are moving. Now, bring 2.88 to, you see the way we are moving. We are guessing, no? We are just guessing, isn't it? So we know that the solution cannot be here. Now, put 2.8 here. We are now working between 2.88 and 3. It's like I'm searching for something. I've checked the first office there, it's not there. The solution is likely, the thing is likely to be what? In the other offices. I checked the next office is not there. I will not look at those places again. That's what we are doing. Now, when you now get to, so you now get 2.94, and then we have minus 0.05. We are still getting closer to the solution. You bring 2.94 here together with this. So 2.943, and now having 0.47. Are we together? We have overshoot. What did I say? You are looking for something, you don't pass them. You are looking for cold drink, you are past the shop. Because we are looking to get to 0. But now we are sure that our solution is now, the bus has taken you further from your bus stop. What do? You come back. When you come down, you come back. If you can trek, you trek. If you cannot trek, you take another motor back. You know you are past the solution. Getting 0.47, we know we are past. So what do? Now, we will not go beyond, we will not go back. We retain 2.94. When we now do the new solution now here, 2.943, we got 2.97. We're going to bring 2.97 here. Hello? We're going to bring it under what? Under B. We cannot increase A further, isn't it? We cannot increase A further. We bring between 2.97 here. We find the what? We find the average again, 2.955. You will bring it here. You see what we are doing now? We are now replacing B. We are no more replacing A. And we see that that overshoot is now reducing. I've gone beyond my bus stop. I'm retracing my step back. Can you see? Because the function was 0.47, now 0.21, now 0.08, which means you are past your bus stop, you are coming back to your bus stop now. Now you continue to go like that. In this, they give you how many decimal points you want. They say with 4 decimal points, they are okay, they stop there. Otherwise, you can continue. If you are not satisfied with 4 decimal points, you can continue. Do you know a possibility? When you are going back, you can still pass your bus stop again. You don't get sense, man. Eh? Slap yourself. You pass your bus stop for the first time, you are coming back, you can still pass it. How will you know that you are passing it again? When you get another negative here. Hello.
Hi.
When you get another when you get another negative, that means you don't pass again. You retrace yourself back. So this is the calculation he has done. I now took interest. I now went into MATLAB. I went into where? MATLAB. These explanations are now used to code a program to do this job for us. Between the time I ask you people to come for meeting and you didn't come, it was then I did this program to evaluate. So I will show you the program. Yeah. I want to show us the program. I cooked it this afternoon. The MATLAB program, we should show, I don't know what's problem with it, but I've already copied it somewhere. Let me show you in Word. This is the MATLAB program. I said, once you understand the solution, I will post this document on the group. Once you understand the solution to a numerical problem, you can develop a computer program to solve the problem. The idea of numerical analysis is to make a problem solvable by the digital computer. The computer can compute faster than human beings and calculators. You are not going to be tested on programming in this course, but it's good that you should know programming. This is just an illustration. So this is the program code. I said MATLAB program, for example, 2.2. Is any of you that is very good in MATLAB? Okay. So let me now show you the results. Okay, the thing is slow, the MATLAB is slow, but I've already recorded the results somewhere. This is the program, and then let me show you the results. This is the MATLAB results. This is the MATLAB results for the program. You can see, can we try to compare and contrast? Now, in their own case, let me bring can you see the two together, the way I'm placing it? Can you see the two together?
No, sir. No, sir.
Yes, sir.
See my screen. I'm displaying two. Are you able to see? Who is able to see here?
Yes, sir.
Somebody can see here. So
We
you
can
can
see.
see that in their own, our results are different because they made some approximations. You can see that in line 3, they wrote 2.88, whereas it is 2.875. Now you can now see that what they got is 2.9428. You can see that what I got is also 2.9428 after 19 attempts. How many attempts? After 19 attempts. Can you see it? Keep going, my friend, if you are going. So you can now see after 19 attempts. In my own case, I did it in such a way that, let's look at this column, -9. It became -5.85. You can see you are getting towards the solution. Then there's an overshoot. We are bringing it back. And then we got to another negative. Hello? That means we are past the bus stop again. When you are going, you pass a tanker for your bus stop at tanker, and then you are coming back, you still pass it. So it's changing whenever it's changing from minus to plus, change to minus, we are redirecting the solution. Now, hello, the attempt here after 19, we are correct up to 4 decimal places. We are correct up to 4 decimal places. Who is at the door? Leave the door, please. Leave the door. Now, I made another attempt, and we did it up to 54 attempts. Can you see that this is correct to more than 4 decimal places? Can you see?
Yes, sir.
You can just look at the figures. Look at the figures under that. You can see that it's correct up to so many decimal places. What made the difference? Why the difference?
One is manual, one is with
It is the two of them are not manual. The two of them, what we did is, hello, look at this program. There is something I wrote here. Can you see it? I wrote if absolute fn minus 1 is less than 10 raised to power minus 4. Break. Stop the analysis. Hello, we watch the function we get now and the function we get previously. If the difference is less than 10 raised to power minus 4, stop. But to get it more accurately, you can increase that 10 raised to power minus 4. In the same, when I generated the first for 19 attempts, I used this 10 raised to power minus 4. When I look at the second one, I use 10 raised to power minus 15. That means more job to be done and more accuracy to be achieved. So this is example 2.1. So I think with this, we can say that we have done example 2.2. So we can stop this video here. Thank you very much. Thank you for having me.